call this is theta. No, it is released from rest. This is S equal to 0 you take. So what are the forces they'll be acting? Mg sin theta down the incline. Then mu mg cos theta normal reaction n will act, and I'm not showing it. N and mg cos will act, this is the thing. And initially mg sin theta is telling it first slides down. So therefore it will have acceleration. So now as it slides down, what look at the mu. Mu is proportional to distance curve. No? So the value of mu will keep on increase. So initially mg sin theta will be greater than the frictional force. And because of that, what happens? There'll be an acceleration. And as it slides down, so the value of mu will keep on increase. So at one instant, what happens? Mg sin theta will become equal to mu mg cos theta. It can happen. So in that condition, we will indicate somewhere here. Here it will have some friction. I'll call that as F naught. Here this friction, if you want, you write it F1. Time being, let it be like this. Then again, after this, what will happen? No. The F naught, what will happen? Now the F naught will keep on increase, no? And it become greater mg sin theta. And because of that, what happen? The block will undergo now the retardation. Here the friction force acting, let it be F2. Now I'll show the retardation. So here let it be this acceleration A1. And finally, it comes to rest.
Audio is cracking.
Maybe some network problem from Zoom. Zoom itself is a problem, nothing to do with this. Because I'm almost changed all three networks I changed it, internet connections. Mobile data, I checked it, then the internet. Now, can you hear me?
Yes.
Clearly?
There is slight breaking.
Slight breaking, sir.
Still breaking.
Only a bit, sir, but it is.
Voice clarity is very important. I don't know, today, network. I'll check it once. Can you now hear me clearly?
Yes, sir.
Yes, sir.
Okay, now we'll continue. Okay, this is what the tech, no? This is what the tech given for us. No. Find the maximum speed of the block during motion. Where the maximum speed will occur? You know enough kinematics. So first, what is the type of motion? Accelerated motion. From where to where the accelerated motion? From here to here is what? Accelerated motion. Now this is acceleration, and the remaining part, this will be the retardation. Where the maximum speed will be? Somewhere here. So this should be the maximum speed when mg sin theta equal to f naught. So take help of this condition. First, we'll get into acceleration. What is a1 is equal to? Mg sin theta umg cos theta by m. So this should be equal to a1 equal to g sin theta mu g cos theta. What is value of mu here? Mu, it varies proportional to distance is telling. So mu equal to, shall I write alpha s, where alpha is some constant and s is the distance covered. S is the distance covered. So here I'll assume like this, g cos theta. So this you can write it as now v dv by ds. Only that situation, if you can understand clearly, it'll be rest all mathematics. No. What was our question? Our question is to get that maximum speed. No, there is only purpose here. G sin theta ds alpha g cos theta s ds. Anybody, what should be the limit? Distance covered till it attains maximum speed. Let me call that as S1. So initially I release from rest. So 0 Vmax 0 to S1, 0 to S1. Vmax square by 2 G sin theta S1 alpha G cos theta S1 square by 2. We don't know much information S1. No? Anybody how to get that S1? At S1, when the block is at a distance S1, so what is the situation here? The net force is 0 here. No? Here what happened? Net force is 0. So from that, what we can write it here now? When the block attains maximum speed, when V is V max, net force will be 0. Sir, you can ask me one best question. Why you are saying it when net force 0 only speed is maximum? I think it's based on kinematics here. First, the body will accelerate. But at the same time, what happened? Yeah, what is the motion? Accelerated motion. So what's happening here? Speed increasing, acceleration decreasing. So from initial, so as it moves, speed. Then what happened? Then the frictional force will become greater mg sin theta. Then it undergo retardation. Then comes to rest here. So here only the speed is maximum. So when the speed becomes maximum, net force should be zero. Net force zero means what condition you can write it? Mg sin theta. So what is the value of f naught? So mu mg cos theta. So what will be the value of mu? It should be equal to alpha s1. So what is the value of s1 should be equal to? The value of s1, I'll shift it to the left. What is the value of s1? S1 should be equal to sine theta by alpha cos theta. That should be the value of s1. So that value of s1, I'll substitute here. Okay, got this? So I'll get expression for Vmax. So here I'll write the equation. S1 equal to sine theta by alpha cos theta. Call this equation 1, this equation 2. So what we are going to do further, put 2 in 1. Then we'll get expression for Vmax. Anybody value Vmax after substitution all? Put 2 in 1, solve for Vmax.
Sir,
Ah,
once can you show the question, sir? Sir, here they said that it first slides down and then stops after sliding down a height h, right?
no, read the question, read the question. There's a problem with the reading question. The grammar. It starts from rest and it comes to rest. So what is IT as descended? H finish or no? The sentence is enough.
Yes, sir.
Anybody? Vmax? If you give Vmax value, I'll proceed further. Okay, somebody is saying, giving answer. Huh? G sine theta, G sine square theta.
Sir, 3g sine square theta, sir, by 2 alpha cos theta.
Negative sign is there, no?
G sine square theta by alpha cos theta, sir.
Yeah, this will be the answer. Okay, now Vmax we got. But this is not our answer. Alpha is what we assume, no? That should be eliminated. How to eliminate alpha? Alpha is what we assumed it, no? Alpha is not given for us. Alpha is what we assumed it. As in theta into S. Work done by the friction. So this should be equal to F into ds, 0 to S. What is this? Total distance covered. So here, so one simplest thing like it was released from rest, it will descend height h, no? And this is S. It will start from rest and it will end up here at rest. Okay, let's go for mg sine theta S. Now what is the friction value? Mu mg cos theta ds. In fact, what is mu? Mu we assumed it equal to alpha s, no? Okay, this should be mg cos theta ds. So 0 to s. Solve for this, we'll get expression for alpha. or expression for alpha. That alpha we can replace. So first we'll do one thing. There's a mathematics, no? So I'll get expression for s is equal to. So shall I directly go for it? The s will be equal to 2 sine theta by alpha cos theta. This is the thing. And other side we have is sine theta equal to h by s. So h in place of s I can write it as h sine theta. So there's equation 3, there's equation 4, equation 5. 4 and 5. Cos square theta. And what I should do this value? This should be substituted there, no? Sine square theta in place of alpha I should substitute here. So alpha cos theta by sine square theta. So substituting this is the equation 6. Put 6 in 3. I'll get that maximum speed equal to how much? B max equal to root of GH by 2. Because only H is given, that's why I'm expressing. If we had given alpha, then we would have stopped there only. Okay, look at the frictional force. Frictional force can be variable also. It need not be constant. It varies with the distance covered.
Sir, we won't get S to be that, no, sir.
I'm not getting what you are asking. No problem. Check somewhere. You are only do correction from your side.
Yes, sir, we are not getting S to.
I'm just replacing, no, like what all I should replace? Sine square theta by alpha cos theta. GH by 2 will come. How you can you cannot use conservation of mechanic energy because here friction is a non-conductive force. That's why I applied work energy theorem. Check your calculations. Check your calculations. Check your calculation because I didn't do any big mathematics here. Come for this.